Hey, morning everybody. Welcome to day 3, the final day of our Python bootcamp. Like yesterday, we're going to start today with an activity. So you will need a partner for this activity. You can't do it alone. And each pair of people needs to come up and grab one stack of cards. If we have an odd number of people, then Matt can be someone's partner. So you need to partner up and come grab cards. Cards up here. Somebody come grab cards. So what we're going to do this morning is a card game in maybe a loose definition of game. But your objective is to sort the cards in order from lowest to highest. One person will be the player and the other person will be their bot. If you are the player, you have some specific rules. The player cannot look at the face of the cards at any time until they think they are done. When they think they are done, they can flip them over and see whether they won or lost. There are no points in this game. It's just win or lose. You either got it right or you didn't. So what you can do, though, as the player, is you can hold up exactly 2 cards to your bot, and you can ask them one question and one question only. Which of these 2 cards is larger? So somebody tell me, is it this one? Left hand. Left, this one? Okay, so that's the only question. If I were the player, that's the only question I can ask of my bot. And the only answer that the bot can give is which one is larger. Now, once I have that response as the player, I can do whatever I want with the cards as long as I don't break any other rules. I can arrange them in any way that I want in the space in front of me. I can stack them up. I can hold them in my hands if I want to. There are no rules about how you arrange the cards. It's totally up to you. You just can't look at the cards and you can't ask anything besides which of these 2 cards is larger. You can ask that question as many times as you want. You can ask it about the same card multiple times if you want to. There are no rules about that, but you can only ask about 2 cards. You can't hold up 3 cards and ask which one is larger, only 2. And you also cannot ask, is this the largest card in the deck? That is not a legal question. The only question you can ask is which of these 2 cards is larger. Now, if you are the bot, you cannot provide any information unless you are asked, and the only question you are allowed to answer is which of these 2 cards is larger. If they ask you any other question, you're not allowed to answer it, and you can't give any other indication or hint like visually or verbally or in any other way. Also, for the bot, ace is high. If you make a mistake and you accidentally say ace is low, that's okay, just as long as you're consistent and you remember that when you're checking their answer at the end. You'll take turns being the player and the bot. So one person will have a chance to be the player first and the other the bot, and then you'll swap so that the bot becomes the player and the player becomes the bot. And hopefully by the end of it, you'll have developed a strategy to sort these cards without ever having to look at them. I'll leave these rules up, but when you're ready to begin, feel free. What's that? They shouldn't be. Everybody should have one suit. Yeah, you'll probably want to make space on the desks if you haven't already.
So because I know
DQ.
whoops, it was an accident. Jeez.
We only accept perfection. Yeah, strategy. So if you figured out a strategy and you're pretty happy with it, one thing you can add to the game is having the bot count how many times you have to ask that question, and that can give you a score that you can try to beat. So a lower score was better. You're more efficient. So what was yours?
You didn't even solve it.
Yeah, that was nice.
So that now
Right. Okay. That's what I told you to do earlier. So it's gonna work out to you right here. You just get which one is Switch. You're right.
No, it's not gonna work out.
There we go.
So I'll let you explain.
Let's go right to the middle.
Options is you can pull out two cards. And you can which one is larger. Just two cards, which and it's like you can do whatever you want. You can arrange them in
That's confusing.
And then after you
long as they're in the sun this way. Alright. See how we did.
Oh, I mixed them up. I mixed them up in the story.
Hey, I'm talking about, yeah. This is the algorithm that you're doing is a very, very safe problem. It uses a lot of ifs.
That's what we should have done. Should have just done the.
So that
You did that for a long time, but that's what I use in this. Literally just put the entire
yeah,
and you
yeah, you did it.
I think we just figured because we totally got that right. I just mixed whenever I was. Watch. I also put it for the first one, or the one in the middle, but it's just a gap because I know. I just took the big one to start from the top.
There you go. Somebody's higher than you.
Yeah.
Just tell me if I'm
I like to make some more than I would just like to use back to check. We got it. So really interesting. Do you have like an end-all be-all solution to this?
Well, I mean, you know, I've only been studying computer science for 3 years.
Well, still, I mean,
But
this is
a
metaphor.
solution to this is pretty easy. Found a solution.
Well, yeah, finding
the
a
hard
solution
part
is
is
easy.
finding
It's a streamlined solution, yeah.
and it's not the most efficient.
It's not the most pretty efficient. Mine probably took longer than yours, honestly. Mine, all I did was I took the next two, and the bigger one, I started from the top, and just compared them all the way down.
That's exactly right.
That's exactly what I did. See, look at you, start percent. Let's see what he does. So this is what I did originally. But yeah, it just seems like one at a time is going to take a lot longer. No, it's the same. So this is exactly the same. The only difference. Just think of it. So you have so this is
I think I already know.
But you can say if you that's just
It's just faster. It's more than or you go that far.
just don't experience.
I may have taken an engineering 101 class before.
I just write sorted or sorted on a piece of paper. I don't know, sort of chart from.
Yes, actually.
So
There is I think there is a list of
Yeah, that's what he showed us this the other day. That's what I was saying.
Very good. Now you can do that sound with those instructions. That's the real challenge. Has everybody had a chance to be the player at least once? I have today.
Oh, that's funny. Have you seen, I don't know what I was watching, where they're like, cars against glass, rather than deck against glass, and it's like supposed to like get into the glass. And everyone's like, ooh, like shooting glass. Yeah, so he had a deck car, so he was like, all right, look at your card, and then the diesel guys like, this is this card. I have not been to this insurance space, I don't know how she said.
It was like, I feel like I remember.
It was terrible.
It was glorious. Oh, that was funny. Disregard.
Yeah, we're gonna go for just a couple more minutes. No, they don't need to go over. I mean, they should be if you beat the game.
So we have a working.
Okay, I'm gonna pause you guys there. And I know that there are a couple people still going. So I'm going to give you just a minute to try to memorize where you're at in your algorithm, because later we're going to be downloading something and that may take a couple minutes. So you might be able to come back to this later. So try to make a mental note of where you're at, where your algorithm, so you can pick back up later on. But we're going to move forward. Normally when I do this activity, I have like a week-long boot camp where we're not just learning Python, we're learning other stuff as well. But usually I make people actually try to write down their algorithm for sorting the cards. But I'm not going to make you do that today. Hopefully, though, this is a simple enough activity. You can do it anytime with anybody as long as you have a deck of cards or any set of things that can be ordered. And just so you know, there are literally hundreds of different strategies for solving this puzzle. Solving the puzzle isn't actually the hard part. The hard part would be writing the program to solve the puzzle, a set of instructions that would work for any size of deck of cards that are shuffled in any order. So we're going to start today with where we left off yesterday. We had one more topic to cover, and that is to mute you. There we go. That is on exceptions and error handling. So we're going to demonstrate this with a very simple program. It's not something that you absolutely have to know in order to write a program, but if you do learn how to do it, then it will make your programming experience a lot nicer and safer, so that your program doesn't crash when something that you maybe could have expected actually happens. I thought that this video was totally appropriate. It shows this baby putting down some pillows before he crawls off of the bed so that he can land safely. And that's basically what exception or error handling is in programs. It's putting down some pillows so that when you crawl off of the bed, you don't injure yourself. You can land safely. Come on, little guy. Yeah. All right. Okay, so let's fire up Visual Studio Code. And we're going to close everything we had open yesterday. And I'm going to create a new file. I'm going to call it guess.py. This is going to be a very simple guess the number game. And I think we actually did something like this either on day 2 or day 1. But we'll just get it started here. We're going to come up with a random number. So we're going to use the random module. Some number between 1 and, let's say, 1,000. And then we'll have the participant make a guess. And we'll continue looping while their guess is not equal to the number that they're supposed to be guessing. So to acquire their guess, we'll use the input function. And we can add a conditional statement to tell them whether they're too high or too low. Okay, so real quick, based on what you see here and maybe what you saw yesterday, is this program ready to go? Is this program complete? Will it run without errors? Can you see any potential problems with the code that I have on the screen? Say it one more time. Good. So yeah, you're really close. If they whatever they type in here, the input function always returns a string. It always returns text. Even if they type in a number, it will be text. And here I'm trying to compare text to a number. And that's obviously not going to work. So what I need to do is I need to convert that text. Actually, let's run it so that we can see that. I'm going to put these side by side. So here it's asking for my guess. I'm going to enter number 10, and Python errors out right away, and it says you can't use the less than operator between a string and an integer. And I'm gonna show you another way to troubleshoot this type of issue. In my debug panel, we saw this on day 1, but we're gonna check it out again. I'm gonna go ahead and close my terminal and open my debug panel. And down at the bottom, I'm going to check this box that says uncaught exceptions under the breakpoints section. Just going to check that box. And now when I run my program, I'm going to use this play button up here to run it and tell it that it is Python. So now it's running. It opened up the terminal for me down here, and it's asking for my guess. So I'm going to guess again the number 10. Now this time, when the exception happened, the program didn't crash. Instead, let me put this back on the bottom. Instead, it stopped on the line and highlighted the line where the error occurred. So now, not only do I know that, hey, something happened, it's got this big red box in front of me. Something happened. I know exactly where it happened, which hopefully will clue me in on how to fix it. So it tells me an exception occurred here. This is a type error. The less than symbol is not supported between strings and integers. So one of these must be a string and one of them must be an integer. And if I hover, you might have noticed, if I hover over a variable, Visual Studio Code will tell me exactly what's in that variable. You may remember that we're also able to see that on the left-hand side here in our debug panel. We can expand this locals and we can see all of our variables there also. So I can hover and see the values. I can see that guess is a string, number to guess is a number, or I can see them over here in my locals window. So I need to convert one of these to a string or the other one to an integer. If I convert them to strings, the comparison operator will work, but it will be an alphabetical comparison, and that's not what I want. I want a numerical comparison, so I'm going to convert this string to a number. And I'll just do that as a separate variable. Just using the int function, sending it the guess variable, which was a string, and saving the result in this separate variable. I'm going to hit this green loop button to restart my debugger, and it'll start my program over from the beginning. So now it's asking for a guess, and if I enter a number this time, well, I got another exception. And the reason why I get that exception is because I forgot to change my comparison. I created a new variable, but then I forgot to use it. So I'll just do that down here. Okay, so enter my guess for number 10, and it tells me I'm too low. It didn't crash that time because now it's comparing numbers to numbers. Good. So what if, though, what if I enter something like what Jasmine mentioned, something that's not a number, like the word cat? We can see that it crashes again, but this time in a different spot. This time it crashed on line 10, where I'm trying to convert whatever their guess was into an integer. It says value error, invalid literal for int with base 10 cat. Python does not know how to convert the word cat into an integer. The answer is obviously infinity. So now I need to figure out how I want to handle this. I could, before I do that conversion, I could try to write some if statement to check to see if all of the characters inside of the string that they entered are numerals, but that would be kind of complicated. And fortunately, Python doesn't make you do anything like that. In the same way that I told Visual Studio Code to catch exceptions for me and display them inside the IDE, I can actually write code to catch exceptions inside the program. So to do that, I'm going to hit this stop button here to stop the debugger, end the program execution. And I'm going to put a little bit of space before I try to do that conversion. And I'm going to add a new keyword that you haven't seen yet called try. And you'll notice that there's a colon at the end of that keyword, which means that if I hit enter, it's going to automatically indent, just like an if statement or a loop. Python's expecting now a block of code. What block of code, what list of instructions do you want Python to try to do? In this case, I want it to try to convert that string to an integer. So I make sure that that line of code is indented underneath the try. I'll outdent on the line before that and type the keyword except, followed by a colon, and then enter again. And you'll see that it indents once more, because now it's expecting another block of code, another set of instructions for it to execute in the case that something happens that's unexpected, some exception, something exceptional happens when this line of code is executed. So here I might just print out a warning. That is an invalid guess. So I have a try statement and an accept statement. The try statement defines a block of code. Those instructions will be attempted to execute by Python. If an exception occurs during that time, then the code inside of the except block will be executed from that point on. If you have extra code, that code will only be executed if this code does not error. If there's an error here inside the try block, Python will immediately jump down to the accept block. So let's see if this works. We'll run it. We'll run it with the debugger. So here it's asking me for a guess. We'll make sure that I can still type the numbers. And tells me 500 is too high. What happens if I type in a word like cat? It tells me that is an invalid guess. So the program didn't stop. Visual Studio Code didn't show me any errors. Everything's working as expected.
It did tell you it's too high.
It did tell me that it's too high. And the reason why I did that is because this code is not part of the try except block. It's outdented. It's on the same level as the try and except. So after it's done doing this, Python will continue execution as it normally would. So if I don't want it to print these things unless the guess is okay, where should I put them?
Yes.
Yes, very good. So I can just cut those out and paste them right in there so that they're also part of the try. So now let's see what happens. Let's restart the debugger. I'm going to enter a guess of 100. Tells me that's too low. Now I will try to enter a guess of 500 as text. And it just says that is an invalid guess. It doesn't tell me that my invalid guess is too high. It doesn't tell me that my invalid guess is too low, because as soon as this line of code happens, if it is an error, if some exception happens when it's trying to do that, it will skip everything else in the try portion and jump straight down to the accept portion. So now I have some rudimentary error handling inside of my code. And I can play this game. 500 is too low, 750 is too low, 875 is too low, 922 too high, 900 low, 893 too low, 897, 898, 899. Yes, good call. So up here in my while loop, I'm still using guess instead of the guess as int. So I should change those. And to make it a little bit easier for myself, instead of having to do that the whole way, I'm going to add a breakpoint. You saw that on day one. I'll show you again. In the margins here, I can click. You see those red dots pop up. I can click there to set a breakpoint. You'll notice that it actually pops up down here in my breakpoints list. It tells me guess.py on line 7 has a breakpoint. So now when I run the debugger, Python will pause when it gets to that line of code, and I can see the number that I'm supposed to guess is 642. And I'll tell it to continue. So if I guess 500, it should say too low. And if I guess 643, it should tell me that's too high. And if I guess 642, hopefully our program stops. And it does. And of course, if we're really industrious, we can add something after the while loop, just so that the player knows that they've actually won and the program didn't just exit unexpectedly.
I've got a quick question.
Yes.
How do you X out of it?
So if you want to force a loop to exit, which, for example, if you're searching through a list of things and you find the thing that you're looking for after like the third item, and there are 1,000 items in the list, you probably don't want to continue searching through the list. So you may want to exit the loop early. Or in the case of this program, we could change it slightly to make this a infinite loop, but then we can tell it if the guess is too low, else if the guess as int is too high. And if it's not too low and it's not too high, then that must mean it's exactly right. In this case, we want it to exit. We can do that with a break statement. The break statement tells Python, whatever loop you're currently inside, stop that loop. Let's try that out. Let's do that with the debugger. I still have my breakpoint turned on, so it's going to pause. It's not going to pause. It's going to break. Don't actually know what it's doing right now. We're going to close Visual Studio Code and restart it. All right.
So if you're stuck in a loop.
If you're stuck in a loop in the terminal, the trash can icon there will kill that terminal. And so any process that's running inside that terminal will also be killed. If you close Visual Studio Code, all of the terminals and all of the processes that all of those terminals have will also be killed. All right, there we go. So my number is 632. Enter your guess. 631 is too low. 633, whoops. 633 is too high. 632 is on the money. So even though this looks like this loop will run forever, because I told it to stop when the number is not too low and not too high, then it must be exactly right. And when it's exactly right, I told Python to break out of the loop that it's currently in. And that's exactly what it did. It broke out of this while loop so that it could print this statement here. This is the most basic form of error/exception handling in Python. For what you're doing, this will probably get you by for 99% of the things that you're going to do. But if you're looking at other Python code, you may see a slightly different syntax. So I want to show that to you here just so that it's familiar, at least, if you encounter it in the future. You may, question?
Just one quick comment for the beginners. There's a very common beginner's mistake. You put inner loop initialization statement. So every single time when you run the loop, you initialize the variable again. And that is a mistake I made before. So I just want to share with you.
Yeah, you have to be cognizant of your code and remember that loops will always execute from top to bottom, and every line inside of it will be executed every single time. So one thing I'm going to do here, I'm going to add, so what I want to do is maybe I want to print a special message depending on the type of error that happens. There may be multiple errors that are capable of happening, and I may want to handle different types of errors in different ways, and Python allows you to do that. So in order to do that, you need to know what the error is, what specific type of error you want to handle, the name of that error. So right now, my error, I'm not going to see it because I have it inside this except block, this try except block. I'm not going to see the error at all. So I have no way of knowing what the error actually is. So to figure out what it is, I'm going to add another checkbox to my breakpoints over here, the one that says all exceptions. So even though this exception is going to be caught by this try except block, Visual Studio Code is still going to pause because I'm telling it to pause on every single exception. So let's run our Python code. It's going to ask us, well, it's going to break on our breakpoint and tell us the number is 305. That's fine. Then it's going to ask us for a guess, and I'm going to force it to error here to cause an exception by typing in some text. And we'll see that it stops here, even though it's inside of our try except block. I told it to stop on all exceptions. So it stops here, and it tells me the very first thing, it's a value error. And if I want to put in special code specifically for value errors and not for other types of errors, then I can add that to my except statement. Now, this except block will only handle value errors. And I'll demonstrate that just by making some other type of error. For example, I'll do 10 divided by 0, which is mathematically impossible, right? The answer would be infinite. But this, well, we'll prove that that's an issue by doing it in the Python interpreter, interactive interpreter. We'll do 10 divided by 0. We can see that gives us a 0 division error, which is different than a value error. So let's run our code again. And I'm going to turn off all exceptions this time. So it's only going to catch uncaught exceptions. So if I run my Python code in the debugger, number to guess is 353. Well, it's not going to get there, so we'll just run it. It doesn't matter what I do. It's going to stop there and tell me that that 0 division error occurred, and it's uncaught. I'm not catching all exceptions anymore. I've only told Visual Studio Code to catch things that I have not caught. And since I'm not catching this 0 division error, my Visual Studio Code pauses there. Let's see what happens if I just run it from the command line. My program crashes on that. If, however, if I take that back out, and run it again, it will still catch the value errors, but it's not catching the division by 0 errors. Putting in the, I guess I have to, putting in the except without any special type after it will catch every other exception. So if you see something that looks like this in other Python code, you just need to know that they want to do something specific for value errors and something else for every other kind of error. And if you wanted to, this code isn't doing any division, but if we wanted to, we could catch that 0 division error here. And we could do other things as well. There are a ton of built-in exceptions that come with Python that you can handle or not handle if you'd like to. But the simplest way, especially when you're just getting started, is to put something like this in so that you can catch all of the exceptions at once. Any questions about error handling? Okay. We're going to move forward then with our next slide deck. Question here. Oh, yeah. Is that better? Whoops. So in today's presentation, we're going to talk about Python user interfaces and the use of third-party code. Just a quick note before we do, though. If after yesterday you felt like, wow, that was a little overwhelming, I learned way more, or I was exposed to way more than I thought that I could handle, that's an okay way to feel because we've probably already covered 2 semesters worth of computer science in just these 2 days. Obviously, you haven't done as much homework as you probably would have in those 2 semesters, but the ideas and the topics that we've covered are what you probably would have covered in at least 1 and probably 2 semesters of computer science. So if you're moderately keeping up, you should feel pretty good about that. Yesterday, we learned how we can organize our code into modules and packages, which makes it easier for us to navigate and organize our code. It also makes it easier for us to share our code with other people if we wanted to do so. And fortunately for us, there are a lot of people around the world who do exactly that. They write Python code and they make it available for anybody to use for their projects. Also, fortunately for us, there are so many people doing this, and it's such a popular thing to do, that there is a dedicated website that indexes a lot, not all, but a lot of the Python code that people have made available for other people to use. That website is PYPI, I believe it's pronounced PyPI, ambiguous, so pypi.org. I'm going to open that now in a browser. And all this website is, it's just an index of Python packages that you can use in your projects. We see right here on their front page, there are 148,000 Python projects. And if you're doing something, chances are somebody has written some code that you can at least use to make your life easier. You may not find code that does exactly what you need it to do, but it can certainly save you a lot of steps. For example, I'm going to search for Discord, and Discord is like a chat room service. Where we can see that there are 218 projects in the Python package index that match the search term Discord. There's a music bot, there's some other custom bots, a wrapper. All of these wrappers just make things easier to talk to Discord. Travis bot, I have no idea what that is, but it sounds interesting. All kinds of stuff. There are 11 pages of these things. Maybe you need to interact with Twitter. There are 1,700 projects that match the search phrase Twitter in PyPI. Maybe you're doing some type of psychology. Maybe you learned how to spell. There are 45 projects that match the keyword psychology, which is a pretty broad search phrase. One of the first ones that comes up there, actually, I guess the first one, is PsychoPy. And PsychoPy is actually a pretty interesting project. It's a very large project, and we are using it right now in our lab for some experiments. What's cool about PsychoPy is that if you install it, it's written in Python, and you can use Python with it, but it actually comes with a graphical user interface for defining a study and executing that study. So if you use PsychoPy, you don't even have to write any code. You can just drag and drop to design your experiment. We haven't used it in that way, but that's one of the things that it touts. Let's see, what else? What else might you want to do? Maybe you want to interact with Google Sheets. There's stuff for that. Maybe you want to work with Excel. There's stuff for that. Oh, maybe let's search for SPSS. There's stuff for SPSS. So many things available to you in the Python package index. And this is an official website. It is operated by the same people that operate Python itself. So you can feel okay about the things that are on there, but it's also important to know that anybody can submit a package to the Python package index. It's not difficult to post malicious code. So one thing that you want to look at when you're considering using a project, let's just open this one because it seems pretty conspicuous already, is that usually they'll have a link to the project. And in this case, I can tell by the icon that this is going to take me to GitHub, which is a website for sharing source code. And this project apparently is dead. I would not use this code in my project. Let's look at a different one, though. Let's look at this guy. So they have a link to their Bitbucket page, which is like GitHub, another place to share source code. And this page is not dead. And if I clicked on source here, I would be able to see the source code for this project. And I can feel much better about using this project in my program, because somebody who's going to try to do something malicious probably isn't going to publicly post their source code of their malicious intent. Probably. No guarantees, but another thing that you can look at when you're on the Python package index, you can look at the development status. And there is, you can also look at some statistics. So hopefully this one has some. So we can see here that it's used by a bunch of other projects. If a bunch of other people are in this project, 129 people have starred on GitHub. So this seems like a pretty trustworthy package. Generally, there's not a lot of malicious code, but it is possible for people to upload bad things. So just know that when you're using code on there. But the website is operated by the Python Foundation, the same people that distribute Python. So most of the stuff's on there is pretty good to use. Some of the other things that I want to point out, there is a package called, a set of packages actually called PyPI, which is huge in the scientific community. Most scientists that are doing programming are doing programming in Python. And anybody who's processing data in Python is probably using some of the SciPy packages, which includes NumPy, Matplotlib for creating graphs, and I forget what this one is, but it's adorable. So we'll just appreciate it for that. PsychoPy we've talked about already. And the last one that I want to talk about is Qt. Qt is actually a C++ project. It is an application framework written for C++. It basically makes it easier for people writing C++ programs to do so. It includes a graphical user interface framework, a set of widgets that you can use for designing interfaces in C++. Fortunately for us, though, there are bindings for that C++ library in Python. People who make Qt have taken the time to make it so that it works with Python as well as it works with C++. There are multiple versions of those bindings, and as you're looking, if you are on the internet and you're looking for advice or tips or hints or answers about using Qt with Python, you might see some of these different names come up. So I just wanted to include this slide to clear up some of the confusion. Basically, there are two projects. The short version is you want PySide 2. PySide is Qt for Python. They changed the name recently as sort of a rebranding, because originally, a little bit of history, Qt was developed by Nokia, and then they got rid of it because they stopped developing mobile phones. And so they didn't have a need for it anymore, yada, yada, yada. A bunch of arguments broke out. Eventually, Qt became its own separate company. And they originally had some bindings for Python that they called PySide, but they didn't do a very good job of keeping them up. And another company decided that they would do a better job. And so they created PyQt, which is this name here. And PyQt is very, very popular. In fact, we're using it for some of our projects here in the lab. PyQt works with an older version of Qt, though. It works with Qt4. There is a new version of Qt, Qt5, that has a lot of nicer things in it. So now there's a PyQt and a PyQt5, and there's also a PySide and a PySide 2. PySide just means that if you see the name PySide, that means it's actually officially supported by the Qt company, the people that make Qt. If you see PyQt, then it's another company called Riverbank Computing, and they do their own thing. Until recently, until actually just a couple months ago, PySide 2 is incomplete. But now, as of like a month and a half ago, PySide 2 has officially been released for Python 3, which is what we're going to use in our demonstrations today. And it's what I recommend that all of you use for your programming. It's not Qt. Let me see what my next slide is real quick. Yeah, okay. Qt is not the only option for making graphical user interfaces in Python, though. You can use, Python actually comes with a built-in GUI toolkit called TK or tkinter, and you can use that. You don't have to install anything special. It's already there. You can use GTK, you can use WX Windows. There are tons of options, maybe not tons, but there are many options for creating graphical user interfaces with Python. I like Qt the most, so it's what I usually recommend to other people. You get a lot of nice things with Qt that don't exist in some of those other windowing toolkits. So that's what we're going to use here. Now, Qt does not ship with Python. We have to install it ourselves. So we're going to modify this slide real quick. I'm going to take this bit out. We're going to install PySite 2 from pypi.org, the website we were just looking at. I'm going to pull it back up here so that you can see that it's in there. I want PySite 2 because that is the bindings for Qt5 from the official company. You can see here that they do link to their homepage, and we can download the source code for it. If I want to install it, you'll notice that this download link takes me, if you look at the status bar down here, the download link takes me to a separate web page. I could click on that and go download it from the Qt website, but because PyPI is so popular, because so many people use it to install packages into their Python installation, there are actually command line tools that you already have for automatically installing this into your Python installation. So inside Visual Studio Code, I'm going to open my integrated terminal. If I can find it. I can't find it, but it's Control and then backtick. Should point it out. It's in here. Oh, there it is, right there. Integrated terminal. I'm going to open that up. I'm going to close this little thing, and I'm going to type the word pip. I'm just going to hit enter there so I can see what some of the options are. There are a bunch of options there. It takes commands such as install, download, uninstall, freeze, list, show, blah, 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 blah. Basically, you can use pip to install code that other people have made available. If you want, you can package your code and you can email that package to somebody and they can install it with pip. But we're going to use pip to automatically download packages from PyPI. So from the command line here, first thing I'm going to do is I'm just going to do pip search and type Qt. I want to search for all of the packages for Qt. And we can see that there are a ton. Fortunately for me, though, I know exactly what I want. I want PySite 2. So I'm going to do pip install PySite 2. We can see that it's downloading it.
It's way faster than mine.
Are you on secure?
I'm sure you're hardwired.
If you are running on Mac, so real quick, so we can see that it installed. It tells me, it gives me a couple warnings there that this script is installed in a path that is not part of my path, so I wouldn't be able to run this directly. That's okay. And it's also telling me that my pip is out of date, and it tells me exactly how I can upgrade pip, and I could do that if I want, but I don't really care about that right now. I just wanted to get PySite 2. So now, if I run the interactive Python interpreter and try to import PySite 2, it does it without error. If I don't have PySite 2 installed, I'll just uninstall it real fast. Pip uninstall PySite 2. It asks me, are you sure you want to delete all this stuff? Yeah, I'm sure. It's going to take just a minute there. And now if I run the interactive terminal and try to import PySite 2, it gives me an error. It says, there's no module named PySite 2. That doesn't exist. You don't have it on your system. I can't find it. Now I'll install it again. Pip is a really handy tool because installing Python packages in a place where your Python interpreter can find them can be a little bit tricky, but pip handles all of that for you. You just tell it what you want it to install. It'll find the correct version for your version of Python in your operating system and put the files exactly where they need to go. So now I have PySide2 installed. Oh, you can use the CLS command on Windows to clear. If I have a bunch of stuff in here, CLS will clear. If you're a Mac user, you can type the word clear. And in most operating systems, you can also just use Control-L. That doesn't work everywhere though, but it works for me here, so that's what I usually use. Okay, so if you haven't already, go ahead and pip install PySide2 so that that'll get going. And I'm going to demonstrate just a little bit of PySide2 for us on the screen. I'm going to make a new file. I'm going to call it GUI.py. And the first thing I'm going to do is I'm going to import some sub-packages from PySide2. I'm going to say from PySide2 import. I'm going to pull in 3 packages that I always import when I'm doing Qt stuff. The first one is Qt widgets. The second one is Qt core. And the third one is Qt GUI. When you're working with Qt, you always have to have an application. So first I'm going to create an application and put that inside of a variable. App equals Qt widgets.q application. You can see Visual Studio Code is smart enough. It already knows that this thing exists because it found PySide2 inside of the directory where pip installed it for me. So it's already providing me with some auto-completion stuff. And if you're following along, a little bit of what I'm doing here is boilerplate. And by boilerplate, I mean that it's code that you'll do pretty much every time that you're writing a Qt Python program. I'm going to create a Qt application object. It's expecting a list of arguments. I'm just going to send it an empty list for now. And I'm going to skip down a few lines. And the last bit that I need is I need to tell that program to execute. So you can see the autocomplete there. It tells me what I need. So that's a function. And in between there, in between creating my application and running my application, I'm going to create some GUI element. In this case, I'm going to make a button. I'm going to give that button some text. And then I'm going to tell that button to display on the screen. And let's try to run it now. So there we go. I officially have a graphical user interface. My button doesn't do anything yet, but it's there. It's on the screen. I can maximize it. Now it's a big button. I can move it around and I can close it. And that's that. If I wanted to add multiple things, this is just showing one button. Maybe I need 2 buttons for my program. I'm just going to copy and paste that for demonstration purposes. I'm going to put button 2. Now let's see what happens when I do this, what it's going to look like. Well, now I have button 2. I don't see, oh, I should give it a different, I should use a different variable for that. So now I have button and button 2. Run it again. And now I see still just the one, but it opened 2 windows. So if I move this one, it gave me 2 windows, a window for each button. So it is possible for me to put these in the same window because I probably don't want 2 separate windows. It is possible for me to put them in the same window by creating some type of container. And it's okay if you're, I wouldn't bother trying to follow along code-wise with this because I'm just demonstrating the cumbersome way to make you appreciate the less cumbersome way here in a moment. So I'm going to create some type of container. I'm going to give that container a layout. And then I'm going to add those buttons to that container's layout. So here I've created a container. I created one button. I'm not going to show it. I've created a second button. I'm not going to show it either. Then I've added those two buttons to my container's layout. And now I'm going to display the container. And there we go. Now I have two buttons on my screen. And maybe I want them to be vertical instead. I'll change this H box layout to be a V box layout. There we go. Now they're vertical instead. If you wanted to, you could build your user interfaces using code like this, but making changes, even small ones, can be very cumbersome. And so I don't recommend doing that unless you have a very, very simple user interface. An alternative is Qt Designer. If you installed PySide 2, then Qt Designer, if you installed PySide 2 on Windows, then Qt Designer came with it. The only challenge that you have is finding it. If you are on Mac, then you have to install the full Qt toolset, which is pretty big. It's like between 1 and 3 gigabytes. And if you're on Windows, you can install the full Qt toolset if you want to, but I wouldn't recommend it because the only thing that you probably need out of it is Qt Designer, and that comes with PySide 2. So if you want to, you can download Qt. If you're on Windows though, or Linux, you don't have to. You can just find it in your PySide 2 installation. So unfortunately though, one of the nice thing about using pip is that the nice thing about using pip is that it installs things into the appropriate folders for you. In this case, though, we actually need to know exactly where pip installed PySide 2 to so that we can find the Qt Designer program. So I'm going to run the Python interactive terminal. I'm going to import PySide 2, and I'm going to print out to the screen an attribute of that PySide 2 package, a magic attribute called __file__. And here it tells me exactly where that PySide 2 package lives. It lives in this folder, which I would have had a difficult time finding on my own. So I'm going to just highlight that and copy it. Then I'm going to open an Explorer window and paste it in. And it doesn't like it because it has those extra slashes in there. So I got to take those extra slashes out. Okay, so now I'm in the place where pip installed PySide 2, and right there I see designer.exe. So I'll give you a moment to find your installation of PySide 2 and your designer.exe inside there. If you need help finding it on your machine, just give us a holler and one of us will come over and help out. So I typed Python and then I typed import PySide 2, and it is case sensitive, so you need a big P and a big S. Yeah, so and then after I imported PySide 2, I asked for the file that belongs to PySide 2. So I did PySide 2 .__file __. I know that seems like a really hokey way to get to this program, but doing it this way saves you like 2.5 gigs of hard drive space. Unless you're on Mac, then this doesn't save you anything. Sorry, Mac people. Yes, 2 underscores before and after the word file. And this is actually a handy trick for, you can do this with any Python package or module. If you, maybe you created a Python package and you accidentally named it the same thing as a built-in Python package, and you wanted to know, hey, is this package my package or the built-in Python package? This is a way that you could test that. You could ask for the file associated with that package or module and find where it's saved. If it's saved in your folder, then you know that it's yours. If it's saved somewhere else, then it's probably not. So once you have the file name, you can just open Explorer window and put the folder in the address bar. You'll notice on mine, I did not include that very last part, the init.py, because that's the file that initializes the PySci2 package. I just want the folder that the PySci2 package lives in. So I stopped after PySci2, and that's the folder that I want. Once you find the designer program, you can go ahead and double click to launch it. For those of you who can't do it right now, maybe you don't have your laptop or you're still downloading or you're on Mac, and I apologize if this doesn't work for you. Just a quick intro to Qt Designer. Qt Designer is known as a WYSIWYG editor. That stands for what you see is what you get. In other words, we can drag and drop components onto the screen to lay out our interface in the exact same way that we want it to appear to our users. We don't have to know anything about the source code behind it. All that we have to know is what the things are going to look like. Some of the nice things about Qt Designer is that the files it saves are just plain text XML files. They end with a .ui extension, but they're just plain text. So we can open them in any editor. So if you didn't have Qt Designer installed somewhere and you needed to make a small modification, like maybe you wanted to change a label that said one thing and you needed to say something else, it's very simple to do that, even with just Notepad, if that's all that you had available. You can open the .ui file in any text editor. We have a couple of options for how we use those .ui files. A question? We have a couple of options when we create UI files in Qt Designer. One thing that we can do is we can convert the UI files into Python code, which might be useful if you wanted to see how, if you wanted to do it manually, you could. But an easier way to do it is just to load the file at runtime. You can tell Python to find the UI file and create the window from it. And that's what we'll demonstrate today. I'm going to peek my next slide. So switching back to Qt Designer, when I first open it up, it comes with this dialog for creating a new form. You can use any of these if you want. We're just going to start with just a plain old widget. A widget is sort of the most fundamental component in Qt. It does absolutely nothing except to occupy space on the screen. We're going to create a new widget though, and we're going to put child elements inside of that widget. So I selected widget and I hit the create button, and it gives me this form. On the left-hand side of the screen, there are a list of widgets that I can add. On the right side of the screen, I have my object inspector and property editor and resource browser. I'm going to close the resource browser for now because we're not going to use it. And I kind of like having that real estate. I'm also going to close this action editor. We're not going to use that right now either. And the signal slot editor, we're also not going to use that. So now I just have my object inspector and property editor. That's all that I want. I have just a blank form here. I want to add some stuff to it. Maybe we want to build, I don't know, let's say we wanted to build a tic-tac-toe game. So I'm going to add some buttons. I'm just dragging and dropping from the buttons on the left into my form here. And I want 9 of these, so I'm going to add 9 of them. You'll notice that when I bring them over, it's allowing me to put them wherever I want. I can be pretty careless about placing them onto the thing. And I can also change the size of them by dragging on the handles and moving those around. Right now, this form, this widget, has no layout associated with it. So every individual component is in charge of keeping track of where it's supposed to be. If I wanted to be a little bit more organized than that, though, I can tell this widget to use a layout. After I've thrown my components on there, I'm going to right-click and just select on the layout menu. I'm going to pick one of these. There's layout horizontally. Well, actually, we'll do them all so you can see what they do. Layout horizontally, lays them out horizontally. Control-Z to undo. Layout vertically, does exactly as you might expect. Layout in a grid, lays them out in a grid. And layout in a form looks kind of weird because I'm using buttons. But if you had labels and then text boxes for people to type in, then a form layout makes more sense. For this demo, though, we're going to do layout in a grid. And you'll notice that it not only did it arrange them so that they're all lined up, but it also modified the size of them so that they all occupy the same space. So if I resize my window, I'll see that the buttons grow with it because the layout is telling the buttons exactly what they should be doing. And the layout is updated every time I resize the window. Now, if I want to modify properties for widgets on my form, I can click on an individual widget to select it. You'll notice that it selects it over here in my object inspector. I'm going to bring this over a little bit. So that's push button 3, that's push button 5, that's push button 9. And down below in my property editor, I can see all of the properties associated with that button. So the first one under QWidget is this enabled. If I uncheck that, we'll see that the button becomes disabled and it can no longer be clicked. If I want to change the property back to its default, it gives me this little red arrow here. So I can try to change it back to its default. I can change properties about its size. So right now it has a size policy that says that I'm going to expand it. It says that its horizontal policy should be the minimum. Its vertical policy should be fixed. Let's see what happens if I change this. Maybe I'll change it to this expanding option, where you can say, oh, now that button expanded and it took up more space. These buttons aren't set to expand though, so they won't do that. Maybe I want them to. I'm going to hold Control and click on all of the buttons, and I'm going to set that property, that vertical property, to expanding so that they all have an expanding vertical property. And I don't want to resize, they all fill up that space, and that's much nicer. While I have them selected, I also want to modify the text. And I could scroll through here. And one thing that you might notice when I'm scrolling through here is that there are different categories. So there are properties that belong to all Q objects. There are properties that belong to all Q widgets. There are properties that belong to all Q abstract buttons. There are properties that belong to all Q push buttons. Maybe I don't remember exactly the property that I want to modify, whether it belongs to Q push button or Q widget or whatever. It has this nice filter feature up here, so I can just type. If I want to change the text, I'm just going to type text. And I can see there's only one text option, and it's this one. So I'm going to change that to click me. I've changed that text property for all of those buttons. So this isn't much of a UI so far, but I'm going to go ahead and save it to show you how we can load it inside of our Python code. So from the file menu, I'll just select save. And I'm going to save this file in the same folder as the rest of my Python code, which is in my documents and then Python stuff. And we'll call this grid.ui. I've saved that. And now in Visual Studio Code, just to show you what that file actually looks like, it shows up here in my browser. And you can see if I click on it, it's just plain text. But I can actually see the text for those buttons appears right inside here. Click me, click me. If I saved it as just grid.ui. Yeah. So if I want to use this .ui file in my Python program, the easiest way to do it is with a class that comes with PySide2. So I'm going to import it from PySide2, a new package. I'm going to import QTUI tools. I can't hear you. Yeah, it's saved in the same folder as everything else. If you want to, you can save it in a different folder, but you'll have to remember what that folder is in the code later. To make it easy for now, we're just going to save it in the same folder. So I want to, I'm going to save, or I wanted to import this extra package here, this QTUI tools. And fortunately, I've done enough Python with Qt programming that I knew this off the top of my head. There are many things that I don't remember off the top of my head, though. And so I keep a bookmark for the official Qt documentation. In my web browser, I'm going to go to the Qt website. And I'm going to click on developers here because that's what we are now. And then I'm going to click on resources. Just FYI, this isn't the actual way that I get there, but I'm trying to show you how I might if I couldn't. And it's, yeah, I don't even know where to go from here. So normally what you probably would do is you would just search for the thing like load UI file in PySide2. And the first thing that comes up is the QUI loader class in the Qt for Python documentation. So if I click on that, it's going to take me straight to the official documentation for PySide2. It tells me that this QUI loader class has a bunch of functions available to it. And if I scroll down, it actually has some sample code that shows me how I can use it. I can create, looking at this, I can create a QUI loader, and then I can load a file, and I can tell the loader to parse that file, and then I can add that widget to some layout. And there's more, there's sample code in there. This documentation, though, this is the official PySide2 documentation. It's actually sometimes hard to find if you're just Googling for stuff. Frequently, what you'll find instead is the regular Qt documentation. So this is the Qt 4.8 version, which is the older version. Maybe we'll add Qt 5. There we go. QUI loader class, Qt UI tools 5.11, Qt documentation. So this documentation is for C++ users. The first one that we saw, the one that said Qt for Python, this is the documentation for Python users. If you need sample code, you'll probably want to use the Python documentation. But one thing that you'll notice is that the C++ functions and the Python functions are exactly the same. For example, here I can see there's a function called add plugin path. This is the Python documentation for this class, add plugin path. If I look at the C++ documentation, I'm going to go to the full list. Actually, I'm just going to search for it. Add plugin path exists inside the C++ documentation as well. There it is. Add plugin path. In the Python documentation, there's a function called available widgets. There's a function called available widgets here. Or layouts, available layouts, available layouts, available widgets, available widgets. If you switch back and forth, you'll see it's pretty much one-to-one. The C++ documentation and the Qt for Python documentation match almost exactly because the Python bindings are made from the C++ bindings automatically. So they should be one for one. A little pro tip though, instead of Googling for things, if you know that you want to go to the Qt for Python documentation, most browsers, maybe not Internet Explorer, I don't actually know, but definitely Firefox and Chrome allow you to add custom search engines to your browser. So here in the Qt for Python documentation, it has this quick search feature. I'm going to try to search for something here. Maybe I'll search for Q widget. And it takes me to this search page where it does the searching, and then I can click on the thing. I can actually add that search to my browser as a keyword. I'm going to right click, and I'm going to click on this add a keyword for this search. This is in Firefox. I can show you how to do it in Chrome as well. It's pretty much the same thing though. So I can give it a name here. I'm going to call this Qt for Python documentation search. And I can give it a keyword. I'm going to give this the keyword QTP, short for Qt for Python. And I'm going to hit save. Now that I've done that, I can use that as a keyword search in my address bar. I can just type QTP, and then whatever it is that I want to search for, Q widget, and it will automatically take me to that page. Without me having to know where this full URL, I can just add that thing. Now, and you can do that in most modern browsers. It's very nice. Although I think there is one problem with this particular one. I'm going to search for something else. Maybe I'm going to search for Q scroll bar. I don't even know if that's a thing. And we notice that when I did that, it took me to the Q widget page. So I need to change the search a little bit. So I'm going to go to my bookmarks. Bookmarks. I'm going to click on show all bookmarks so I can find the one that I just added. There it is, Qt for Python documentation. I'm going to edit it. And then the location, down here we can see that it has Q equals Q widget. And I don't want it to be that. It added this Q equals %s at the end. The %s is whatever you're searching for. So I'm going to take that %s and put it where that Q widget was. Now if I try that again, QTP, this time searching again for Q scroll bar. Now it searches for a Q scroll bar. QTP. Maybe I don't remember the name of the thing. Maybe I know it's some kind of checkbox. I'll just search for checkbox. It searches for checkbox for me, and it searches for a bunch of things. There's a Q checkbox. That's probably what I want. So handy little tip. If you guys want, I can show you how to do that in Chrome as well, but it's pretty much the same procedure. Does anybody want to see that? Yes, no? Okay, no. Yeah, handy tip there. So whenever I'm doing programming with Qt in Python, I will usually keep a browser window open just so that I can quickly search for whatever it is that I'm looking for. Like if I need some sample code. That works for any search engine, by the way. You can do that with IMDb. You can do it with, I don't know what search engines people use. Ask Jeeves. All right, got one snicker. Okay, so yeah, so we'll go back. We were looking at the GUI loader class so that we could figure out how to actually load some stuff. I can see that there's a load function here, and if I go to the very top and scroll down just past it, it gives me some sample code here. And the way that they're doing it in their sample code, at least in this one, they're loading this from a resource file. And I can tell that just because I know Qt and I see the colon at the beginning. So we're not going to follow this example. I'm going to give you an easier one. I'm going to delete all of this code. So I just have my app. I have my Qt UI tools package that I realized from the documentation. And from that Qt UI tools package or module, there's a class called QUI loader. I need to create an instance of that class and store it in a variable. And then I can use that object to load my file. My file is called grid.ui. So I'll just send that as text, grid.ui. And then I'll tell it to, I'll need to put that into a variable. We'll call it window. And then I'll tell that variable window to display. There we go. So that's all of the code that you need to create this entire thing. And even if it were more complicated, the Python code for creating that window would not need to change. You would just change your design. And actually, we'll do that right now. We'll change the design. Maybe we don't want a button in the center. Delete that one, save it, and run my Python program again. Made no changes to the Python code, just changed my design, and that button has now gone away. So Qt Designer, very handy tool. Highly recommend that you get used to it. It's not very complicated to use. For the most part, it's drag and drop. There are some little gotchas, and maybe we'll design some user interfaces so that you can maybe see some of those gotchas and what I do with them. But generally, it's pretty straightforward. Before we go into more detail, though, a little bit more about using Qt in general. The Qt application framework, by the way, I keep calling it Qt, but officially it's pronounced Qt. I don't know, I never got in the habit of calling it Qt, but that's officially, it's called Qt. So maybe I'll try to do that for the rest of the day. The Qt application framework is an event-driven graphical user interface framework. And most GUI-based frameworks are also event-driven. And what that means is, instead of writing our instructions from top to bottom, do this, do this, do this, do this, do this, we'll instead structure our program so that we tell Qt what to do when certain events happen. We won't tell it when to do those things. We just tell it, hey, when that thing happens, here's a list of instructions to perform accordingly. Those things can be button clicks, they can be scrolls, they can be keyboard presses, they can be data being received on a network interface, they can be somebody closing a window or maximizing a window. Any kind of event that the user might perform, or any kind of event that a program might encounter is an event that we can tell Qt in Python what to do in that case. The pattern, the sort of paradigm that Qt uses for this, they use kind of a unique nomenclature. They call them signals and slots. And so if you're looking at the Qt documentation for Python, you'll see these words used. And internally, though, you should just think of them like this. A signal is an event that can happen. And a slot is just a function that is attached to a signal, that can be attached to a signal. So events and functions, that's all that they really are, signals and slots. There's a ton of really cool, like for computer science nerds, really cool stuff you can do with signals and slots. But for what we're probably going to ever be doing, just know that a signal is an event that can happen, and a slot is instructions that you can attach to that event. So we'll demonstrate that here with our program. Each of these buttons has a name, and we can see their names in the object inspector. And we need to know their name if we're going to attach events to them. So for example, if this button is clicked, maybe we want something to happen with it. So I'm gonna simplify this. I'm gonna get rid of some things. There we go. So I have 1, 2, 3 buttons. 1, 2, 3 buttons. And I'm gonna give them all names that I will remember in my code. I'm gonna call this top button. I'm gonna call this one middle button. And I'm gonna call this bottom button. I'll save my file, and I'm going to switch to Visual Studio Code. And when I have those buttons, I can listen for events that happen on those buttons. And if I'm not sure what events might happen to a button, or maybe I know that, like, obviously a user can click on it, but maybe I'm not sure that clicking is the name. Is it clicked? Is it clicked on? Is it clicking? I don't know. So I can look that up in the documentation. I'm going to just type QTP and then the name of the class that I'm looking up. In this case, I use Q push buttons. tune. There's my Q push button. And you'll see that it first lists some functions and then it lists some slots. It doesn't list any signals directly, and signals are the ones that signals are the events. But the reason why the Q push button doesn't directly emit the signal is because it actually gets that signal from abstract button. And if I read through the detailed documentation, it tells me exactly that. A push button emits the signal, PySci2, Q widgets, QT widgets, Q abstract button, click. And I can click on that. That's a link. It'll take me straight to there. It tells me that when you click on that button, that it's clicked. It's not even click. I thought it was click. It's clicked. So in my code, I'm going to reference my window. My window has a set of properties. One of them is top button. Top button has a list of attributes, one of which is the clicked signal. And to that clicked signal, I'm going to connect some slot, some function. Right now, that function doesn't exist, but I'm going to create one called top button clicked. This is the name of a function that I'm going to define. I'll define it up here. And you'll notice that when I'm referencing this function down here, I'm not going to put open and close parentheses because I don't want to call this function right now. I just want Qt to know about this function so that it can call it later. So I'm going to reference the function itself without calling it, so no parentheses at the end. And then inside that function, I'm just going to print a message to the screen so we can see, we can prove to ourselves that something happened. Top button clicked. So if we run our program, we have our 3 buttons, the changes we made to our UI. If I click on the bottom button, nothing happens. The middle button, nothing happens. If I click on the top button, though, I can see in my terminal, it tells me, hey, the top button was clicked. It printed out the message that I told it to. And if I had any other statements underneath this function definition, those would be executed as well. But right now, I just have the one, and so that's exactly what happens. So this is how I can attach slots to signals, how I can define functions that can be executed when some event occurs inside my program. Any questions so far? Yeah.
In the Windows top button,
Down here?
It's gonna execute right away?
Yes.
Okay.
Yeah, we'll see that. We'll go ahead and demonstrate that. So before the window even popped up, it said top button clicked. And you might notice that this button doesn't return anything. If it did return something, that result is what would be passed into this function call. So because this returns nothing, by default, functions return the value none, which we learned about yesterday. And so the effect of this is that I've told it to connect none, and that's not what I want.
One more quick question. In the software course, which is part by the our program, Visual Basic was offered part of the course, right? Is it feasible for Ballistic to replace it with Python, the UI?
In my opinion, it is possible to replace everything that we're doing at Wichita State with Python. Okay. We can show a little bit more with button clicks later, but I want to make sure that I cover one more thing, and we're down to our last hour here. So another very useful class inside of Qt is the Q timer class. This is important because we're no longer providing just a top to bottom list of instructions. We're doing everything based on events. But what if you want something to happen 10 seconds after the window is displayed? If we tried to do that normally, like maybe we want to change the text of the top button. Right now, the top button just says "click me." Maybe we, after 10 seconds, we like really want to get the user's attention. So we'll add in a sleep. So we need the time module. And then after we show the window, we'll say time.sleep for 10 seconds. Actually, we'll make it shorter just so that we don't have to sit here and watch a screen for 10 seconds. We'll say 3 seconds. And then after that 3 seconds, we'll reference the top button and tell it to set its text to capitalized. Click me now. Let's see what happens if we try to run this code. I get a blank screen. And after 3 seconds, the screen is no longer blank. And I can see that it did the thing that I told it to do, but I couldn't see anything beforehand. Let's run it one more time. I also cannot click on anything, and I get the spinning wheel, and oh, now all of my stuff came in. It's definitely not behaving the way that I want it to. And that's because we have to sort of change the way that we're thinking into this event-based manner. So if we have to do everything based on an event, and we want something to occur 3 seconds after the program is started, after the window is displayed, all that we need to do is to create some event that will occur at that time. And that's where the QTimer class is handy. The QTimer class has functions for doing 2 types of timers. One is an interval timer, which is just something that happens repeatedly at a certain interval, like every second or every 1/30th of a second, for example. And then there's a single shot or a one-shot timer, which is something that just happens one time. In this case, we just want a single shot timer. So I'm going to reference the QTimer class. And if I didn't remember where it was, I can always search my Qt documentation for timer, and hopefully I'll find QTimer in there, and it'll give me information about how to use it. I can see it's part of the Qt core module, so I'll just reference it that way, Qt core, which you'll remember I imported by default up here. That's one of those packages that I always import. Qt core.QTimer. It has a function called single shot. The first argument to that function, in case I didn't remember, I can always refer to my documentation. The first argument to that function is the number of milliseconds that it's expecting. And there are 2 different signatures here. This is the one that I'm interested in, number of milliseconds and then the receiver. So I know that I'm going to put in 3,000 for 3,000 milliseconds or 3 seconds. And then I want it to perform some function. So I have to define a new function. Set button text loud. And now I can delete this other code. I'm going to take that out. I'm going to put this code inside of the function that I still need to define. So up here, I'm going to define set button text loud. I'm going to plop that in. So now, hopefully, when I run this, I don't have that time.sleep anymore. So I can actually take this out. I don't have that time.sleep anymore. So my screen hopefully doesn't lock up like it did last time. But after 3 seconds, this single shot timer should execute, and this function should be called. It says, click me. I can hover over things, and then after 3 seconds, it changes. And if I run it again, it's doing things like I expect it to. Nothing's locking up. Everything's happening when I do it. So this is the event-based approach to accomplishing that same task. The other type of timer is the interval timer. So that's the single shot timer for just doing something one time. If you wanted to do something repeatedly, like maybe we want to every second we wanted to increase some count, I'm going to create a variable called count and set it equal to 0 and define a function called increase count. And that function is going to modify the value of count to increase it by 1 and print that to the screen. Very simple function. If I want that function to occur on a regular basis, so every second it will increase, I can use an interval timer for that. So down here, I'm just going to create a new instance of the QTimer class. I'm going to set its interval in milliseconds. There, it's giving me a hint there. It says you want milliseconds. So 1,000 milliseconds is 1 second. So every second, this interval timer is going to go off. And now I just need to connect this interval timer to this function. So every second, this interval timer is going to emit a signal called timeout. And I can connect that the same way that I connected the clicked signal from the button. The interval timer has a timeout signal that I can connect to a function. In this case, I'm going to connect it to the increase count function. Again, I'm not calling the function here. I'm just referencing the function. Now, it looks like I have everything that I need, but if I run it, we don't see anything printed out to the screen. It seems like my code is not running. And in fact, it's not. The reason why it's not is because I didn't tell the timer to start. Now the timer has started and we can see it running down there. It's increasing this count variable every second. And even though that code is running and it's doing that thing every second, it's not locking up my user interface. I can still interact with everything just like I normally would. Another thing that we can do, maybe I don't want to start this timer with the program. Maybe I want to wait until they've clicked on the bottom button. That's a very simple change to make. I'm just going to grab a reference to that bottom button. Bottom button. It has a signal called clicked, just like all other buttons. I'm going to connect that signal to some function. I want that button, when it's clicked, I want it to start the timer. So what function do you think I should put in here? Any guesses? Up to this point, I've been creating functions for all of my signals to connect to. And I could do the same thing here. I could define a new function called start interval timer thing and have it do the interval timer.start. But this is a function that already exists. And it takes no arguments. So it's a pretty prime candidate for being a slot that I can connect to this signal. I'm just going to take this and paste it right in there so that when the button is clicked, it will start the interval timer. I run my Python program. It's not counting. My other timer still ran. And as soon as I click this button, it starts the timer that I wanted it to. Did that make sense? Oh, all of that plugged in? Okay. So yeah, so this is event-based programming. And if you're doing graphical user interfaces, you'll want to do your best to think in this event-based way. Because if you don't, then you'll end up with frozen graphical interfaces, which maybe you've seen that in other programs when it's doing some like really slow task that the whole program seems like it's frozen. That's because they're not doing it in an event-based way. They've programmed their thing wrong. Okay. These are just some hints about what else you can do with Qt for displaying media. Q labels can be used for displaying images in a very simple way. If you want to do a very complicated graphical thing, like you need to draw circles and lines in very specific ways, you can use the QPainter class. I'm going to pull that up real quick. To do that type of drawing, we'll see down here that it has a bunch of functions for doing exactly what you might want: drawing arcs, drawing ellipses, drawing convex polygons, drawing pictures, drawing lines, drawing pi segments, drawing pictures, drawing points, polygons, polylines, rectangles, text, etc., 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 etc. So if you need to do something complicated, you can do that with the QPainter class. But generally, if you just need to display an image, you can do that with a Q label. It doesn't like immediately, if you're in if you're in Qt Designer, you might use this, the widget box, you might use this search feature here to search for image. And you'll see there's no image widget. How do I display an image? You can do that with a label. We'll just plop in a label in between these buttons. It's displaying text by default, but if I PixMap is the property that you'd want to change. So we'll demonstrate that real quick. Let's go to our web browser and maybe just find an image of, we need a link. There's a, yeah. I'm going to save this image as, I'm going to save it in the same folder as the rest of my stuff. Link.jpg. And now in my Qt Designer, I can reference that. I'm going to hit these 3 dots here. No, I'm not. I'm going to choose, I'm going to hit the down arrow and hit this choose file. I'm going to tell it to use link. There we go. Now we have link. Maybe I want to center him. I'm going to search through my things here and see if there's like a center. There's an alignment property, and we'll change this align left to align H center. There we go. Now we have link. See if he works in our program. Well, he's adorable. So Q labels for images, don't try to search for an image widget because such a thing doesn't exist. Q labels can do that for you. You can also use, where did my slides go? You can also use the Q media player class if you want to play audio and video, which is actually really nice because normally if you're programming in Python and you want to play audio, playing audio in different operating systems is different. But Qt makes it so that you can use the same code regardless of what operating system your users are running. I think we can probably demonstrate that if you guys want to see it. Question?
When you play your file, either an audio or file, it's gonna be a separate thread or in the same thread.
It'll be, so actually we'll demonstrate it real quick. I'm gonna make we need some sound. I'm gonna go to BXFR, which is just a silly website for making sound effects. It's Flash based, so hopefully I have a browser that runs Flash. And we're gonna just generate some sound effects here. Let's randomize in a couple times and see what we get. Oh, I muted my audio. I don't like that one. That's a nice long one. Okay, so let's save that sound file. We'll save it in the same folder, or actually, wait, we want to export wave file is what we want to do, so that we get a wave file, and it's called randomize7.wave. I'm happy with that, capital R. So let's play that. So I gave you the hint earlier that we can use the Q media player class to play audio and video, but I didn't tell you how, so we need to look it up. We're going to go to the documentation for the Q media player. We can see there's a bunch of functions there. I'm just going to scroll down to the description and see if it shows me some code. And it does. Now, the code that it's showing me, you may notice that this doesn't quite look like Python code, and that's because it's not. Qt for Python is still kind of a work in progress. And other classes that we've looked at today, their sample code was Python code. This is C++ code, though, but it's pretty much the same. There are just a few minor changes that we'll make. So I'm just going to go ahead and copy this to my clipboard, and I'm going to paste it into this top button function. So we'll play a sound when the top button is clicked. Or maybe we'll do it when the middle button is clicked, since the middle button doesn't have a purpose yet. So there's my code. This is C++ code. So I'm going to have to modify it for Python. The first thing I'm going to do, though, is I'm going to get rid of this line. Because what this line is doing is it's kind of like if you had a seek bar in your thing, this would update the position on that seek bar for you. We don't have a seek bar. We don't care about that. I'm just going to delete that line. Right, so the first thing they're doing is in C++, they're creating a new instance of the Q media player class. Change that to Python, we'll get rid of the word new, we'll get rid of the semicolon at the end, and we'll add some parentheses. We do need to figure out which module this is in though, so I'll switch back to the code and go to the top, and it tells me it's inside of Q multimedia, which I have not imported yet, so I will do that now. From PySide2, import Q multimedia. And now I can reference it down here, qt multimedia.q media player. On here, they're using a QURL and this from local file. So I need to figure out where QURL is. So I'm going to just search for it, QURL. I can see that that exists inside of the Qt core module. I've already imported Qt core, so I just need to reference it, qt core.qurl. These dots in C++ just changed to a single dot in Python. And instead of this MP3 file, we're going to use our wave file, randomize7.wave, and we don't need that semicolon. Also, these arrows become dots. This arrow becomes a dot, this arrow becomes a dot, and we get rid of these semicolons. Now our C++ code has become Python code. That was relatively straightforward to do, and let's see if it works. If I click on the middle button, we're expecting the sound to play. It does not. One reason why it might not is because of the Python garbage collector. Oh, wait, actually, the first thing, we didn't connect this to anything. We defined this function, middle button clicked, and we gave it a set of instructions for this function, but we didn't say when this function should actually be called. This button should be called when the middle button is clicked. Okay, let's try it again, see if it works this time. Still doesn't work. It seems like it should, and maybe we want to prove to ourselves that what we just added is actually happening. We're going to add a print statement here, print middle button clicked, just so that we can see something happen when that middle button is actually clicked. We can see that it printed out to the screen when I clicked on it, so it seems like this should be working, right? It's definitely executing that code. We just don't hear anything. I suspect that the reason why is because of the Python garbage collector. And to demonstrate that, I'm going to take this, this player object, and I'm just going to move it down here instead. And we'll see if that fixes the problem. If it does, it'll tell me that we're on the right track. It does. So here's what's happening. When I define, I'm going to put that back where it was. When I define this variable inside of this function, this variable only lives inside of this function. This variable contains a reference to this object that I created, and it's the only reference to this object. Python has a very nice feature called garbage collection. Basically, it manages all of the memory that you use. So when I create this object, if I were doing this in C++, creating this object would occupy some space in RAM. And if I didn't clear that RAM when I was done with it, then my program would have what's called a memory leak, and it would just continuously eat up memory until my program crashed because it ate up all the RAM. Python makes it so that you don't have to think about how to manage memory. And it does that by keeping track of how many references each object has. In this case, I create this object right here, and it only has this one reference, this one variable. But because this variable is defined inside of this function, this variable only lives for as long as this function lives, which means that as soon as this function is done, this variable is destroyed. And once it's destroyed, this object has no more references. Nobody is referencing this object once this variable is destroyed. Python sees that nobody's referencing this object anymore, and it wipes it out of memory for me. So if I don't want it to do that, if I want it to remember this object, I just need to put it somewhere outside of this function so that it exists forever, or at least for as long as my app is running. So the question we were asking, though, is whether or not playing that sound would occupy the same thread, if it would lock up our UI. Let's see. If I click on this, I can still click on other things while the sound is playing. So it's playing in a separate thread, and I don't have to worry about what it's doing. It will just do its thing. That's such a weird sound effect. I don't know why we ended up on that. I guess because it's long. Okay. So that's how you can play sounds with Qt. If you wanted to play video, you can use the QMedia player to load video files as well. The only thing you'd have to add to it is a QVideo widget to actually display the video. So you'd use QMedia player to play, just like we did with the sound, but you would have to attach it to a QVideo widget in order for the video to show on the screen somewhere. Okay, so that is everything slide-wise. That is everything that I had planned. We have about half an hour left, so I just want to demonstrate more things that you can do inside of Qt that may be helpful for you inside of your programs. One thing that I'm going to demonstrate is how we might animate stuff inside of a program. So I'm going to get rid of these buttons. I'm going to simplify. So now I just have link. And I'm also going to break the layout. Right now, link occupies the entire form because that form has a layout, has a grid layout. I don't want that. I want to be able to move link around wherever I want to. I want to be able to make him bounce off of the walls. So in order to do that, though, I have to break this layout. So I'm just going to right-click on the form, go down to Layout, and then select Break Layout. And now there's my link. I can move him wherever I want, and I can resize him also. And by the way, you notice when I resize him that it just starts to crop him. There is a scale checkbox, so I can click that, and now he'll be scaled. And unfortunately, you can't lock the aspect ratio. I'm going to make him just a little bit smaller so he bounces better. So there we go. Now we have link. I'm going to save that form. I'm going to get rid of all of the button stuff. I don't care about that anymore. I'm just going to get down to the bare bones here. Just going to get my app and my window and nothing else. So let's make sure that that much works. There we go. There's my window. I have my link. He's not doing anything interesting yet. I want him to move around the screen. So I need something to tell him to move, to change his position. So I'm going to define a function called moveLink. And I'm going to, what did I think? It's just called label right now. I'm going to rename that to link. Link label, just so that I remember that it's actually a label. So I'm going to say window.linkLabel. And if I want to move him, but I don't remember how, of course, I can always look in the Qt documentation. But for the sake of time, I will just tell you that it's the move_to function. So linklabel.move_to. And that is expecting an X and Y coordinate. So just for now, I'm just going to put in 1010 so that we can see what happens. Of course, this function isn't being called anywhere, so I need to tell it to be called. So I'm going to create a timer, call it animation timer. qtcore.qtimer. It needs to have an interval, how frequently I want this to run. I want it to run once every 30 times a second. Is how fast I want it to run. So that's 1,000 milliseconds divided by 30, which, by the way, quick tip, in Python, if you take any number and you divide it by another number, it will give you some fractional result. But this function, I just happen to know that it's not expecting a fractional result. It's expecting a whole number. But if I change that single slash to a double slash, it does integer division instead. So it truncates the decimal off. And that's what I want here. If you didn't do that, it wouldn't actually cause any problems. But now you know how to do it in case you ever do. So I also need to connect it to the function that I just defined. and I need to start that function at some point, the timer at some point. I'll just start it right away. When the program starts, it'll start the animation timer, and we should see Link move to position 1010. Oops. Oh, and I get some errors. It says QLabel attribute has no QLabel object has no attribute move to. So I told you that I knew what it was, and I was totally wrong. So we actually have to go look it up. So QLabel is a Q widget, and I suspect that this is probably something that you could do with any widget. It's probably moving something to a new position on the screen. It's probably not specific to a QLabel. So I'm just going to go ahead and jump to a Q widget and look at its functions. It's just move. I thought it was move to, but it's just move. Rookie mistake. All right, let's kill our program and try it again. We can see he's jumped before we could even see him. He's in the top left position of the screen. His top left corner is 10 pixels from the top and 10 pixels from the left. Then the coordinate space for most graphical user interfaces is that the top left corner is 0, 0. Okay, so we don't want to move him to position 1010. We want to move him by some amount. If I look at the code, it doesn't seem like that there's any way to move him by a specific amount. It seems like I have to tell him exactly where to go to. So I'm going to first figure out where he is. And if I didn't remember that, I could just search in here for position, and I might see if I start at the top and search from here for position. That's still not very helpful. I guess you're fortunate that I just remember it, but here is where that function is defined. POS. It tells me that the POS function is going to it actually doesn't give me a lot of help here. It just tells me it's going to give me a point, but we're pretty smart people. If we look at the regular documentation for Qt, Q widget, I think it's actually a little bit more complete. Yeah, so there's more information here. This property holds the position of the widget within its parent widget. So the Python documentation is not complete. The C++ documentation is. So it may be a good idea to keep both of those handy, and I usually do. In fact, I just started using the Python documentation for Qt when I started looking at stuff for this class. I normally reference the C++ documentation because it's pretty much identical. Anyway, so yeah, so POS will give us the position. The position that it gives us, though, is a Q point, and a Q point has an X and a Y. So if we want to change his position, we're going to use his current position dot X plus 10. And I'm going to put these on separate lines just to make it a little bit more readable for us. And his current position dot Y plus 10. So that should move him 10 pixels to the right and 10 pixels down. Let's see if it works. There he goes. And he's gone. Goodbye forever. Maybe we'll slow him down a little bit. We'll cut his speed in half. There he goes. Bye. Okay, let's see if we can make him bounce maybe. We will calculate his new position, and we'll say he needs a direction. For now, let's just worry about his X coordinate. We'll do this kind of piecewise. So now it's just going horizontally. We want to see if he needs to bounce, though. So we'll see if his current position X plus 5, where we want to move him to, if that is greater than the window's width. If Link's current X position plus 5 is greater than the width of the window, then we need him to change directions, which means we need him to remember what direction he's traveling in. So if it's greater than that value, we'll say that his direction is now negative, and we'll make it positive to start. And then we'll use that direction as our multiplier for this 5 times direction. So when direction is a +1, he'll move +5 pixels, which means he'll move to the right. When we change it to a negative value, though, he'll move -5 pixels, which will move him to the left. And it's complaining. We get this error down here, local variable direction reference before assignment. The reason why that's happening is because down here, I am using this variable direction, but remember this variable right now only lives inside of this function. And because this if statement didn't execute, this line of code didn't execute. So that variable, as far as Python is concerned, doesn't exist. I'm trying to multiply by something that doesn't exist because it only lives inside of here. I need to tell it, hey, use that global direction variable. Yeah. So there he goes, and he bounced. And he's not going to bounce on the other side, though, because we didn't tell him to. So we'll add that real quick. If his current position.x is less than 0, then change his direction to be positive. I was going to bounce on one side and then bounce on the other side. Hopefully, ta-da. Now you'll notice that he's only bouncing after he's gone past. We can fix that just by adding his width to our check. Current position.x plus window.link label.width. There you go. Now he's bouncing left and right. And to make him do the same thing in the y direction, we'll just copy and paste that code. We'll change these x's to y's, and we'll change this width for both the link and the window to height. And we need to keep track of 2 different variables for direction now, one for his x direction and one for his y direction. So we'll change this direction. Oops. We'll change this direction to be x direction. And we'll make another one called y direction and set it equal to 1. And that's what we'll use down here, y direction and y direction. And also down here, plus 5 times y direction. Now, hopefully we'll have a link that errors because we forgot to
Change direction on window.
this one. And we need our global y direction. I think somebody said that and I just didn't hear it. There he goes. Now he's bouncing. We made a screensaver. Actually, we can make this a screensaver. When I told the window to display, I just said show. I can tell it to show full screen instead. I can't remember if it's capital S or not, but we'll just try it and see. Nope, that's not a thing. We'll change that S to a capital. There we go. Now we have a screensaver. Looks pretty good. All right. Okay, we have 15 minutes left. What can I show you guys that would be interesting to you? Is there anything that you would like to see that maybe we haven't done so far? To pause a video? Yeah. So we'll look up the Qt documentation for the Q Media Player class. And we'll look at the list of functions down here, and we'll see that we can, oh, it's probably a slot, actually. Yeah, so in the Qt documentation, this is the C++ documentation, they separate functions from slots. So you can use slots as functions, though. So if you don't see your thing in the function list, it might be in the slot list. So there's a play, there's a stop, there's a pause. You can even change the playback rate if you want to speed it up or slow it down. You can create a playlist if you have a bunch of videos that you want to display. Maybe you want them to be randomized, so you can randomize the playlist and then just play the playlist. Yeah, another question. Yeah, so that's a good question. And unfortunately, it's not really one that we have time for. What my recommendation for you right now is that if you want to share your Python code with other people, you should probably just have them install Python. There are ways to package your Python code, but they're not really things that we can cover in 13 minutes. I guess I can introduce you to them, though, so that you can maybe play around with them. One of the ones that I like is called PyInstaller. PyInstaller does not come with Python by default, but it is installable with pip. So I'm going to go ahead and do that now. I'm going to do pip install PyInstaller. It's going to download, and PyInstaller has some dependencies. It requires some other things that also don't come with Python. And pip is smart enough; it figures that out and automatically downloads all of the things that PyInstaller needs and installs those as well. So it's installed all the dependencies. Now it's installed PyInstaller, and now I can use PyInstaller to take a Python program and convert it to a binary file, an exe, for my operating system. So I'm going to take a really simple one, though, this guest.py. Let's just run it, because I don't remember what state we left it in. OK. So that's good. I'm going to kill it and open a new terminal. So our guest.py is good. It doesn't have a lot of dependencies. It's a good example for what we can do easily with PyInstaller. If you installed Python for all users, then you can probably just run PyInstaller. Oh, I can too. So when you install PyInstaller, hopefully it works for you. You can just run PyInstaller, and you can specify the name of a Python file. And if you hit enter, it will analyze your Python file, figure out all of the other code that you're using, and bundle it all together. We can see over here, 2 folders were created, one called build and one called dist. Inside the dist folder, there's a bunch of stuff. One of them is this guest.exe. And you could send this whole folder. You would need this whole folder in order for them to run that one. But if you just want them to have one single file, you can run PyInstaller with a command line argument called onefile, just like that. So PyInstaller -- one file, and then the name of the Python program. It'll rebuild it, and then now we can see we have this single guest.exe, and I'll show that to you in an actual folder here. Documents, Python stuff, dist. Now I have this guest.exe that was created for me, and I can just double click that, and it'll run the Python. Oh, actually it crashed. So can't find module encodings. That's a new one for me. So this is one of the challenges with some of the different packaging options, is that they don't work perfectly, and it takes some time sometimes to troubleshoot them. If you do take that time, you can get it to work. This is not one that I've ever encountered before. And I think it might be because of the way that we have Python installed. I'm going to try something a little bit different. And I'm also going to delete what it built the first couple of times. That didn't work at all. All right, let's just try this. See if it works this time. Nope, it crashed again. Well, that is unfortunate, because that would have been a really cool demonstration. There are some strategies, but this is kind of going down a rabbit hole. If you get a message that says something like it couldn't find a module, in this case, it can't find. It's not even like unzipping it. Let's do it without the one file, because I think that'll probably work. Documents, Python stuff, dist, guess. Nope, that one crashed too. So I think there's some problem with my Python installation. It might have been because when I installed it, I had installed it for myself. I didn't have administrative rights on this machine. I'm not sure what that issue is. That's one I haven't seen before. But normally you can use PyInstaller to create an exe, a single exe from your Python program. And there are other tools that do the same thing. There's one called BB freeze. There's one called C2 freeze. There's one called Pi2exe. They all kind of work the same way, but they all do the same thing, but do it in different ways. So you can try some of those things as well, but it's probably more hassle than it may be worth. It's probably easier just to have people install Python and to send them your Python code. I guess one thing that you can do, we don't really have time for this either, you can zip up your Python code. Let me try to do that real quick. I'm going to take my guest.py, see if I remember how to do this. This isn't the way that I normally distribute my Python code, but we're going to try it out. I'm going to rename this to main.py, and then I'm going to put it inside of a zip file. Send to zip file. Guest.zip. And if you had other modules that you were using as well, you could also put them inside that zip file. And Python can run zip files. It will look for a Python file inside that zip called __ main, and it will execute that file. So if you have like 15 Python files and you want to send one file to somebody else, you can just send them a zip file. And if there's an __ main inside that zip file, then they can run that zip file with Python. What else would you guys like to see? We have about 7 minutes left.
The briefing of the event and the ground speed there.
Okay, yeah, that would be good. So in order to do a key event, let's go to our queue. First, let's look at a queue label or a queue text input or line edit. That's what I want. Queue line edit, which is the standard class for doing just text input. By the way, I just hit Control-R there, or you can click on View and do, oh, maybe it's not View, Window, one of these, Form, Preview, Control-R. So I can preview my form and try it out. So that's a queue line edit. Queue line edit, we can see that it has some signals down here for when things happen, like when text is changed, when text is edited. And so we can connect to those signals just like we connected to the clicked signal of a button. One thing that's different though, on this one, you'll see that it specifies a parameter. So if the text is edited, it will actually send the edited text to the function that it's connected to. And that can be handy because then you don't even need a reference to the thing. Let's make a new one. I'm gonna take out all of this stuff and I'm just gonna make a really simple window. Window equals queue line edit, which is in the Qt widgets module. And it's not really a window, is it? Line edit dot, what was the name of that signal? Text edited dot connect to some function we haven't defined yet. We'll just call it on text edited. And we'll define that function up here. Define on text edited. And when we define this function, we have to specify the parameter. They called it text. We could call it text. We can call it whatever we want, but we'll call it text so that we can print that to the screen. We'll save our file. And then we'll run it. We also don't want it to be full screen. We'll just regular show it. Okay, so now I have a window with just a line edit. If I type in there, we can see that it's printing stuff out to the screen. And that works kind of well, but you'll notice that it's only happening on text edit. So it's not captioning arrow keys, for example. And it's not telling me, like, if I'm in the middle of the text, if I insert something there, it doesn't tell me that this is the thing that was added. It just tells me the like full value of what the text is now. So that may have some limited uses for you. And briefly, the only way to do it the way that you want to is to create your own class that extends from it. So we'll show you that real quick. I'm going to create a new class. I'm going to call it my window, and it's going to inherit from a Q widget. So it's just a Q widget, but it's my Q widget, and that makes me happy. And inside of this Q widget, if I look up the documentation for a Q widget, we'll see that it has a function called keyPressEvent. And that function is called whenever a key is pressed. And it tells me down here, if you re-implement this handler, it's important that you call the base class implementation if you do not act upon the key. Otherwise, it won't bubble up. So these notes are good notes to read. You shouldn't, if you're comfortable with it, if you already read it, then it's fine. But if you should know what you're getting yourself into, because sometimes when you re-implement a function, I'm going to redefine what this function does. Sometimes you may need the default implementation to be executed as well. In our case, we don't really care. We're just going to redefine this function. But if you're going to do something like this, be sure that you read the documentation on it before you do. So then I just converted that C++ code to Python code. So I'm creating a new class called myWindow, which is a type of Q widget. I'm redefining this keyPressEvent function. And I'm just going to, for now, I'm just going to print out whatever this event object is that gets passed in. So now I will make a new instance of my window and display it. And now if I press keys, we can see it's printing that key out to the screen. And that QKeyEvent class has some properties that we can use to figure out exactly which key they pressed, like text or key. So we can say if event.key is equal to qt.key underscore spacebar, then print ready. We'll do that for now. But then now we'll only print something when the key is the spacebar key. Move this so you can see it's not doing anything unless I press spacebar. Oh, that's a little bit different from the signal and slot thing. And it's really just for key presses and mouse buttons. The only signals that are exposed are the ones that make specific sense for that specific widget. So a push button has a clicked event, click signal that will be emitted, and that happens regardless of whether you push a keyboard button or you use the keyboard to press on that key. The button is sort of agnostic to how it gets pressed. And as the programmer, you probably don't care how your user is pressing that button. You just care that they wanted to push that button. So regardless of whether they use the mouse or the keyboard, they pressed it. And so that's the signal that you're connecting to. So the by default, key presses and mouse clicks and mouse movements aren't exposed as signals unless it makes sense for that specific widget to do so. But there's key press event, there's key release event if you're interested in those types of things. There's mouse movement events for those as well. So that's a little bit more advanced for most of what you're doing. You might not need it, but now you've at least been exposed to it, so you'll at least know what direction to go in for that sort of thing. Great question. Any others? Okay, so we will wrap that up there. Just a friendly reminder, all of my desktop session and the audio from the past 3 days has been recorded and it's posted on YouTube. So feel free to go back and rewatch those things. I also have links to the slides in the videos, so you can reference the slide decks as well. I haven't shared any source code with you because I have found that to generally be a crutch for people. Instead of actually examining the source code, you end up just copying and pasting. and you don't get the same experience that you would have from typing the source code. So if you want the source code, what I would recommend to you to do is to pull it up in the video and retype it yourself. If you guys have any other questions about anything Python related or programming in general, I am happy to help out. Feel free to reach out to me, and thank you again for coming.